Namaskar friends, welcome to session 57 in our course on operations management. As we are aware, currently we are discussing the 12th week of our topics in our course on operations management. In the last week our focus is on the topics that are much relevant in efficient and effective management of operations. In the previous session we have covered just in time, and we have seen that how just in time can be used, or what is the importance of this philosophy in the overall management of operations. We have seen that the productivity improves if we are able to eliminate all kinds of wastes that are there in the overall production chain. So the focus is primarily on providing the materials, the type of materials required at the specific time, in the specific quantity, at the specific place. So if we are able to streamline our production flow or production flow line, I think we will be able to save lot of money for our organization. In just in time, if you remember in the previous session, we have written 7 types of waste. So we can avoid the wastage in terms of man-hour, we can avoid the wastage in terms of time, we can avoid the wastage in terms of unnecessary motions of machines and equipment as well as human beings or the workers working in the organization. Similarly, for materials also we can optimize our inventory, or we can totally eliminate the inventory by asking for materials or ordering for materials just in time. So that concept, if we overall philosophically we implement the concept of JIT, we can save lot of resources, which in turn will make our manufacturing or our operations more productive, more efficient and more effective, efficient and productive. Similar is the concept of Kanban, which is a kind of a signaling technique where a signal will be generated whenever there is a requirement for a particular machine or an equipment. So based on the signal system, the pull system, the overall we can say efficiency of the system will be improved. So we will see that if we have a pull type of system, wherever suppose there are 3 machines in a line. So in normal system what we do, we input the material in the first machine, it processes the material and sends it to machine 2, then the machine 2 sends it to machine 3. So kind of a push type of system exists. But in Kanban we have a pull type of mechanism, that when machine 3 will be free, it will send a signal to machine 2 regarding the quantity, the part, the product that is required at station 3 or at machine 3, and the machine 2 will then send that material to machine 3. So that is kind of opposite to our conventional push type system. Here the signaling technique is used to have a pull type of a system. So in today's session, maybe a very brief session of 25 minutes, we will try to understand the basic concept of Kanban, and we will try to see that what are the advantages if we use these signaling system. So earlier there may have been cards or trucks or maybe bins which were used as the signaling mechanisms, but today because of the advancements in the field of information technology, we can use integrated systems in which the triggers can be you can say initiated in the case of emails or fax or SMSs, or maybe on the screens the things may start to flash. So maybe the information technology and internet and the computer systems have made the life much easier for dissemination of information, or maybe sharing of information among the various workstations within the factory or the organization. So today the information sharing or the signaling systems may be entirely different from the systems that were followed maybe 20-25 years ago because of the developments in the field of information technology. But still the basic concept that the signal must be triggered whenever there is a requirement at a particular station. That basic the method of signaling may change, but the basic philosophy will remain same, that whenever there is a requirement there must be a signal to the preceding section that yes, now the material may be sent and I am ready to receive the material and process the material. Otherwise, without any information, the material is produced and it is sent to the next station where it gets piled up. There are delays, there are unavoidable delays, though all these type of maybe delays which can be avoidable, unavoidable, normally lead to unproductive environment or unproductive ecosystem in the organization, and therefore these type of delays can easily be avoided with the concept of Kanban. Moreover, we can always optimize our inventory if we use the Kanban system. So we will see a structured advantages of Kanban system in our today's session. There are number of good books in which you will have the detail related to the Kanban system, but we will try to understand the basic concept that how Kanban can be used for the advantage in managing the operations. So let us quickly first see that what is the concept of Kanban, from where it originated. So Kan means card and Ban means signal. So it is a card based signaling technique which is used in the industries. So card system that controls production and inventory. So in this case we have a pull type of system. Visual pull means because we have cards or containers or buckets, so these are the signaling techniques which will help us to pull the kind of materials that a particular workstation needs. For example, there are two workstations, so the second workstation, whenever it is free, it will send a signal in the form of a bucket or in the form of a card or in the form of a container or in the form of a flash or in the form of maybe internet message or a SMS. So the mode of communication may be different, but the message will be sent to the previous workstation that yes, there is a requirement of 100 components of type 4 or type 5, whatever is the nomenclature for the articles or the component, that this is the requirement at my station or at this station, and then it will become the responsibility of the previous workstation to supply that material to the next workstation or to the current workstation from where the signal has been generated. So it is a pull type of system, whereas in the previous cases in most of the industries we have a push type of system, that whatever is produced at workstation number 4 will be sent to the workstation number 5. So this is what I understand from the concept of Kanban. So card systems, so there can be different options with Kanban. We can have electronic Kanbans, in current scenario most commonly used like fax or emails, warehouse or part racks. So that is another way. The racks where the parts are stored can also be used as a signals. Then Kanban boards, which can be magnetic or cards. So the boards can also be used as a signaling mechanism. Then containers, different colors can be given to the containers depending upon the product types, can also be used as a signaling mechanism. Flow through racks can be used as a signaling mechanism, or supplier boxes can be used as a signaling mechanism. So we have different types of mechanisms which can be used for signaling the requirement or signaling the completion of a particular product or the processing of a particular product. Now there are different types of Kanbans, like Kanban square, which is a marked area designed to hold items. Then there is signal Kanban, triangular Kanban used to signal production at the previous workstation. So we have to send a signal to the previous workstation that the production may start. So it is used to signal production at the previous workstation. Material Kanban used to order material in advance of a process, as we have seen in our section on materials management, that we have to offset, and our offset will help us to order the material. Now suppose the product has to be ready by September 30th. it may require 5 days of processing. So what we will order? We will order ordering lead time for the material is another 10 days. So when we must order? So we must order at least 15 days in advance, so that 10 days is the ordering lead time. So if we order before 15 days, after 10 days the material will arrive at our premises, and then 5 days for processing. So we will be able to supply on the due date. So similarly, the material Kanban is used to order the material in advance of a process. So the signal will be generated that yes, the material is required. Supplier Kanban, this can be a mechanism, any type of mechanism that we have seen in the previous. It can be a electronic Kanban like fax or email. So it will rotate between the factory and the supplier. So we will be communicating with our suppliers regarding the requirement of the material. And if you remember, all concepts are interrelated. In JIT or JIT that we have discussed in the previous session, one of the major drawbacks was that if the supplier is not able to supply the material well in time, our overall process may suffer, and there can be a stock out in the industry, and we may not be able to produce as per the requirement. So if we have a supplier Kanban system, a effective means of communication with our suppliers, the problem of stock out can be minimized, and we will be able to have a one-to-one interaction, and we will be able to get our material well in time in order to maybe have our continuous production line and minimize the effect of a stock out. Now Kanban types we can see with the figure also here. Production or in process Kanban provides production instructions for the work center, as I have already discussed that if there are 3 workstations, from third workstation we will send a signal to second workstation regarding the requirement. So provides production instructions for the work centers, tells the workers exactly the quantity and the type of the part to produce. So the signal will be sent, maybe for example it is not a line type of layout. So line type of layout means that only one type of product is being produced. Now there can be a process type of layout in which we have different types of products being produced on the same machine. Now this machine may be producing 5 different types of products. So maybe as per requirement a signal will be sent to the previous workstation that now type 3 or P3 or product 3 is required, or maybe the sub assembly of product 3 is required. So as is given in second point, it tells the workers exactly the quantity, that is maybe 100, 200, 300 parts, and the type of part to be produced. So that signal will be sent to the previous machine, and accordingly the machine will produce 200 parts of type of the part or the maybe sub assembly which needs to be produced. Used for work centers that produce only one part number or have minimum setups in spite of multiple part number production. So usually in case we will have more efficient and effective signaling system if the machine is producing one part number only, but the volume may change 100, 200, 500, 10,000. So that number is immaterial, but it will be more effective if only one part is being produced, because then once we flash the signal that 500 parts are required, the process or the equipment or machine will start processing the quantity as per requirement. So this is used for work centers that produce only one part number or have minimal setups in spite of multiple part number production. So we can have a rectangular one piece flow production or triangular for small lot production. The different types of Kanban or signals can be sent. So if you have one piece flow production, you will send a rectangular Kanban, or rectangle can represent that, and a triangular can represent small lot production. Then there is a withdrawal Kanban, inter-process Kanban. We can see that delivers orders for parts from a preceding process, specifies quantity and type of parts to deliver from location A to location B. So we can see that we can have inter-process type of Kanban which can ensure us a timely delivery of material from location A to location B. So the quantity and type of parts will be mentioned, and accordingly the things will be supplied from one station to another station when a Kanban is initiated or a signaling has been initiated. Then there can be supplier Kanban, same as inter-process Kanban, except it signals conveyance of part from an outside supplier. So supplier Kanban is a communication between the company and the supplier, whereas inter-process Kanban is within the organization, as it specifies the quantity and type of parts to be delivered from location A to location B. Now there can be other types of Kanban, which can be job order Kanban issued for each job order. Through Kanban, when two processes are very close, it doesn't make sense to issue two Kanbans used where one process directly feeds the next process. So maybe if on a conveyor belt type of Kanban, conveyor belt type of material handling system or the process line, we can use a through Kanban. So if there are two processes happening, need not issue two Kanbans. Common Kanban, when a withdrawal Kanban is used as a production ordering Kanban if the distance between two processes is very short and share the same supervisor. So we can issue a common Kanban also, where a withdrawal Kanban is used as a production ordering Kanban if the distance between the two processes is very short and share the same supervisor. Emergency Kanban, it is a temporary type of Kanban when there is a defect or problem, can be withdrawal or a production type of Kanban. So we can see that different types of signaling techniques are there. Depending upon the function, we have named different types of Kanban: job order Kanban, through Kanban, common Kanban, emergency Kanban. So these are different types of maybe signaling techniques which are used for a specific purpose. Now determining the number of Kanbans is equal to the average demand during lead time plus the safety stock divided by the container size. So N is equal to DL plus S divided by C. So we can see that average demand during lead time, so we can see that D is the average demand over some period, as we have seen in our previous week when we were discussing materials management. We have seen there the lead time and the demand rate. So here we can see small d represents the average demand over some period of time. So it is a demand rate only because it is over a period of time. So we can say maybe 100 components per week, 500 components per month. So this is D is the average demand over some time period. Then lead time to replenish an order, that is L, plus S, that is a safety stock. So this will be a number, safety stock will be a number, demand rate multiplied by the lead time. So demand rate, in the denominator we have time and it is being multiplied by the lead time. So time into time, which means the number only. So we will have number here, and C is the container size. So that will be having some dimensions. So we will see that how many is the number of Kanban. So container size can also be a number which can be 500 or 700 or 2000. So we can see that we have here safety stock, demand rate and lead time, which is giving us one number divided by the container size in terms of a number. So we will get what is the number of Kanbans that are required, specifically when we are using it as a signaling mechanism, that what will be the number of Kanbans required to be sent to optimize our process line. So let us try to understand this with the help of an example. One thing I must address here, that if we see what we have discussed in the beginning today, there can be different types of Kanban signaling mechanisms, and one of them can be the containers, or the here the Kanbans can be the containers. So that is the calculation of the number of containers that are required for satisfying this type of demand rate. So we have safety stock, demand rate, lead time and the container size. Once we know this data, we can calculate the number of containers which will signal the manufacturing or production at a previous station. So we can see the question here, determining the number of Kanbans. You can see the question. D is the demand rate, which was, I have already told, numbers with respect to time. So 150 bottles per hour is the demand rate. L is 30 minutes, that is 0.5 hours, half hour. S is what is safety stock, that is 10% I think of 150 into 0.5. So this is D into L, that is 10% of the demand rate into the lead time, and our container size is 25 bottles. So as I have already told, the container size will also be a number depending upon the size of the container, which is 25 bottles. So here we can see it was given in the problem that the number of containers we have to calculate depending upon the demand rate, the lead time, the safety stock, as well as the size of the container in terms of number. So here we can calculate DL, demand rate is 150 bottles per hour, multiplied by the, you can see, lead time, which is half an hour, plus our safety stock is 7.5, which is 10% of DL. So again we have the calculations here, that is divided by the container size, that is 25 bottles. So D into L plus F divided by C, that is the container size. So we calculate this, it comes out to be 3.3 Kanbans or containers. So we can round up to 4 to allow some slack, or down to 3 to force an improvement. So here we can see that with using a standard formula or standard mathematical technique, we can calculate the number of containers which we need to send as a signal in order to raise a demand, which in this case our signaling system is the number of containers. One more thing I think which I have not been able to make very clear here is the S, that is a safety stock, is a percentage of the D into L, which is the 10% of D into L, that is the demand rate and the lead time. Now tips for effective Kanban, we can quickly have a look at these. So first thing is replenishment process to be balanced to reduce risk of overstocking or potential stockouts. So we have to, in order to have an effective Kanban system, we must keep in mind that the replenishment process has to be balanced in context of that we must not be overstocking, or there may not be a situation of a stock out that we don't have materials for further processing, or the production may stop. So stock outs also have to be avoided, overstocking also has to be avoided. No part to be produced without Kanban signal, and cards to always accompany container from the supplier side until it is out of the Kanban staging area. So it means that nothing will be produced until and unless there is a signal to start the production, or until and unless there is a trigger to start the production. So if you don't have a signal, there is no need of production. As soon as a Kanban is issued, the production must start. Each container must have a separate Kanban card with part number, description and location of consumer and producer. So maybe a Kanban system should have the complete information, the number of parts desired, where they are desired. So all that information must be there with the Kanban signaling system. No part to be produced without a Kanban signal, which I have already explained. Parts to be pulled through succeeding workstations or process. So there will not be any push type of mechanism here. The parts have to be pulled through the succeeding workstations. So no defective part to be sent to the succeeding workstation or process. Amount of output produced should correspond to quantity withdrawn by succeeding workstation. So whatever, suppose there are two workstations, so whatever workstation 2 is desiring, that must only be the output of workstation 1. So amount of output produced should correspond to the quantity withdrawn by succeeding workstation. Suppose workstation 2 raises the Kanban of 100 parts, so workstation 1 must produce 100 parts only. Now what can be the benefits of Kanban? Very quickly we can see: provides quick and precise information, provides quick response to changes, avoids overproduction, minimizes the waste, maintains full control of the process, delegates responsibilities to the workers. Now workers have to issue the Kanbans as per the requirement, and it balances the line as well. Now the benefits of Kanban, again the primary benefits are that it eliminates overproduction. Why? Because it is a pull type of mechanism. Whenever there is a requirement, only then the pull system will initiate the process of production at the preceding section or preceding workstation or preceding machine. Produces only what is ordered, when ordered, and the quantity ordered. So it is a pull type. As is the demand, similar signaling mechanism will be issued, and the production will be according to what is actually desired. So produces only what has been ordered in whatever quantity it has been ordered and when it has been ordered. So whenever there is a demand, only then the production will take place. The secondary benefits of Kanban are: it increases the flexibility to meet the customer demand, because now the machines are not only producing whatever has been mandated during the day. The machines will become more flexible depending upon the signaling mechanism. Wherever in whatever demand is being generated, they will produce the things accordingly. So reduction in scheduling by production control and manufacturing. Competitive advantage by sequencing shipments to customers, what they want, when they want, and in order they want it. So now you can very easily plan your dispatch sequence also, because now you know that how you are going to signal the requirement. As per that only the production planning and control will become a bit easier in this context, so that we are able to produce what the customer wants, in what order we have committed with our customers, what is the timeline for each and every customer. So accordingly we can use this signaling technique to trigger the manufacturing or production, so that we are able to satisfy our customers or to honor our commitments and contracts with our customers. So we can see that in broader context of operations management, if we apply the Kanban system or the pull type of signaling system, it will help in the better management of our operations, and in nutshell will improve the productivity of our organization. So with this we close the today's session. In our next two sessions, our focus will be on the materials requirement planning system. Thank you.